Hello, welcome to this lesson in engineering mechanics. We're going to work this problem in equilibrium. It's kind of a neat problem because we have some kind of a cylinder or a ball that's 500 pounds and it's resting on an inclined plane with an angle of 55 degrees of the inclined plane, and there is a cord or a rope of some kind attached to the ball up here, attached to some kind of ceiling or something like that. You could think of this as a roof or something. And this angle here is 75 degrees. Clearly I didn't draw this properly. The angles don't look quite about right, but as far as the content, that's what we're trying to look at. Now, what we're wanting to find is what is the tension in the cable. This cable we know intuitively must be pulling up, so what is that force? And what is the force exerted on the cylinder? I'm calling it a cylinder, it could be a ball, on the ball by the inclined plane. And we talked about that. We know that the tension in the line must be pulling this way, and there must be a force acting on the plane up. If there wasn't, then the ball would swing. You have to think of it like, what would happen if there was no force there? There has to be a force from the inclined plane on the ball, and so that's what we're modeling here. So the first thing we want to do is draw a free body diagram, and these angles are going to get in the way a little bit, but we'll do our best to talk through that, and then we'll write some equations of equilibrium, and we'll figure out what these two forces really are. So, first of all, let's represent this cylinder, or this ball, whatever it is, we'll talk of it as a ball, as a single point, concentrated typically at its center of mass. And acting on this point, we have this line here, and so this guy we're going to label it T, that's the tension T. And just for completeness, to help me in my equations, I'm going to draw like a little dotted line here. The angle here is 75 degrees. That's basically drawn exactly from what we have on the board. All right, now in addition, there's some weight. This guy's 500 pounds, and that always acts straight down. So I can just label this as 500 pounds, okay? And then finally, there's a third force acting, we talked about this before, normal from the plane. That means perpendicular to the plane directly up into the ball. So if I try to draw that, it's not going to be exact, but basically that force is going to look something like that, and I'm going to label it N. N means normal force. Normal means perpendicular to the plane, normally exerted force from the plane into that steel ball or whatever it is. These are the only real forces acting. You have a normal force there, you have the weight of gravity down, and you have the tension in the line. Okay? Now one more thing I'm going to label on here is, what do you think this angle is going to be here? Well, the angle in the plane was 55 degrees, but we don't draw the plane in the free body diagram. The plane is just there to exert the force in. Okay? But if you think about it enough, the angle between the normal force and the weight is actually the same angle as the angle of the plane there, 55 degrees. And that's actually really important for you to realize intuitively.